Now we have our next presenter, Jatin Chowdhury, who is a DSP engineer who has done quite a few open source things on GitHub. So make sure you check out Chow DSP, and he's going to talk about a alternative to the JUCE's audio processor value tree state class, a class that everybody knows if you've ever built a plugin, and everybody loves or hates. And I'm very curious to hear this talk. So take it away, Jatin.
Yeah, thanks, Josh. Here, let me share my slides here. Perfect.
And I will also link to these slides. Do you want me to link to them now or afterwards? I don't want to
Sure,
speak.
now it's fine, just in case, I guess, anyone wants to follow along. Yeah, so the slides are all online, so you can follow along at home, or if you want to come back to them later, they're all here. So yeah, thanks, Josh, for the introduction and everything. So yeah, I'll be talking about replacing the JUCE audio processor value tree state. So I guess this is probably going to assume that hopefully you've seen some JUCE code before, so at least you kind of have the flavor for what it looks like and feels like. And yeah, there may be a bit, there may be a few parts that go a bit deeper into C++ than maybe some people are familiar with, but hopefully if there's anything that's confusing, we can catch that at the end with questions and things like that. So yeah, this is me. Right now I'm based in Seattle, Washington, and do freelance audio development. Before that, I was at Karma for a little while, and then I worked at Tesla for about a year. And I spend most of my time just making plugins, and a lot of them are open source. So if you want to look at the code, they're all there on those links. And yeah, so I understand why JUCE named this class the audio processor value tree state. I think it's a good name, but it's kind of hard to say when you're talking about it a lot. It's a lot of words to say. So I'm just going to shorten it to value tree state or VTS. So if I use either of those words, just know that I mean the audio processor value tree state. But I didn't feel like using all of the words. So yeah, when I started writing JUCE code, maybe this was 2015 or so, not really many people were using the value tree state. I think it did exist at the time, but I didn't really see it used commonly until maybe 2018 or 2019 or so. So I wanted to give a little flavor of kind of what code looked like in the time before the audio processor value tree state. So this is kind of a sort of a simple example plugin that you might have. And so in your plugin, maybe you have a few parameters. So you have maybe a float parameter, a choice parameter, and a Boolean parameter. And so you would create these just as raw pointers in your plugin class. And we're going to make them null pointers so that they're not uninitialized. And then in our constructor, we'll create the parameters. And we're going to do this for now with the new keyword. And I know you're not supposed to do that, but I kind of wanted to use that specifically to show a point, which is that there's kind of this weird thing with parameters in JUCE where you have to create them yourself, but then you don't delete them because the plugin will delete them. So it's kind of this weird thing where I have to use new to create it, but I don't call delete because the plugin will call delete for me. And then if I were to use something like a standard unique pointer or something like that, then that would cause other problems because then the unique pointer would delete the parameter and then the plugin would try to also delete the parameter. So then you would get like a double delete thing, which can be kind of weird. So next we would call add parameter, and this will add the parameter to our plugin. And so now the plugin is kind of the owner of the parameter and will manage all of the deleting and stuff at the end. And then maybe we need to do some audio processing. And in the audio processing, we need to know the values of these parameters. So we can do it just by calling get or get index, depending on what type of parameter it is. So this is maybe not too complicated, but what's kind of interesting is that as we try to do other things with these parameters, it gets a good bit more complicated. So let's say we want to save and load the plugin state. So if you want to do this, you have to get all of your parameter values and then store them in some format, maybe like XML or something. And then when you want to load the plugin state, you get the values back from your XML, and then you set the parameter values. And this works fine, but it gets a little annoying because whenever you add a new parameter, you have to add a couple extra lines of code here to manage that. And hopefully, if you forget that, you have plugin val or some other kind of automated testing thing that will kind of catch you. But even if you have that, you can run into an issue where maybe you add a parameter and then someone tries to load a plugin state that was saved with an old version of the plugin, and you have to make sure you're handling that case correctly too. So, none of this is crazy complicated. People were doing it, but it's just a little bit annoying to have to go through every time. And then we get to the UI code. So let's say that you want some knob or slider in your UI, and you want to connect that to a parameter. So to do that, you would have to do something like this, where you create your slider, and then you create a slider listener. And then whenever the slider value changes, you have to update the parameter. Whenever the slider starts being dragged or whatever, you have to begin or end your change gesture. And this actually isn't even a complete implementation for linking a slider and a parameter, because we're not handling parameter changes that could come from things other than the slider. So maybe there's host automation, or maybe there's a preset change or things like that. And we would want our slider to change its value for that as well. And we're not doing that currently. So as you can imagine, that's kind of a lot of code. And then you're repeating that code for every single slider, every single button or whatever that you have in your plugin. So that ends up being quite a lot of UI code that, it would be nice if there were a way to not have to write all of it. So that's where the value tree state comes in. So we're kind of going to go through the same exact example, just with the value tree state now. So when you create your plugin, it's basically the same, except that you now have your value tree state instance in your plugin. And then you've got these parameter handles, which are these atomic float pointers instead of your old parameter types that you had before. Then I'll make a function to actually create the parameters. You can do this without a function too, but I think it's a little bit cleaner to do it with. So here we'll create our 3 parameters, and we can do them as unique pointers because they'll get released later on anyway. Then we go ahead and create our parameters and put them in the value tree state. And now we can get our parameter handles and work with them however we want. So this part looks more or less the same, but now when we go to save and load plugin state, we just have this pretty much cookie cutter code that I copied from the JUCE tutorials, and it'll work for you, hopefully just out of the box. You won't need to do anything different or change anything. And then for your UI code, you have these slider parameter attachments or combo box parameter attachments or other types of parameter attachments that will take care of all that UI glue code for you. And now, your UI code, which was maybe 100 lines before, is now maybe, I don't know, 20 lines or something. So you can write your UI code in a way that's much, much neater. So just to kind of recap, when you start using value tree state, you get state saving and loading basically for free. You get undo and redo basically for free. I haven't talked about that, but you can do an undo redo manager in JUCE and hook that up to your value tree state, and it's pretty easy to do. And then you get these parameter attachments, which will push your UI component actions to your parameters and update the UI components when the parameter changes because of some external change. And I think I should also mention that as of JUCE version 6, you actually don't need to use the value tree state to get the parameter attachments. Prior to JUCE 6, you did need to do that, but I guess now you don't. So you might be looking at this and saying, well, the value tree state seems to make everything, a bit nicer. So why would you ever want to replace it? And if you're asking this question, maybe you don't need to replace it. So the value tree state is actually pretty good at what it does. And maybe as you've seen, things were generally a bit worse before the value tree state existed. So if you're thinking about doing this, just know that you might not need to. The value tree state does its job pretty well. And really, there's just a few kind of smaller things that were my reason for trying to, do my own thing. And also, I guess maybe I like the challenge or something. So yeah. Anyway, a few things that I don't like about the value tree state. First is what I call strong parameter types, which I'll demonstrate in a second. Second thing is that there's parts of using the value tree state where it's not very clear which thread certain bits of code will run on. And this can cause some problems, which again, I'll show you in a second. And then finally, there's one spot where JUCE does something that I'm not convinced is real-time safe. And we'll talk about that in a second as well. So what I mean by strong parameter types is, let's say that you have the same kind of example, but now instead of your atomic float pointers, you want the actual float parameter type, because maybe you need some information from it that you can't get from the plain float pointer. So if you want to do this, you have to do these dynamic casts. So instead of calling your get raw parameter value or whatever it is, you have to call it get parameter and then dynamic cast that parameter to your parameter type. And this isn't so bad, but it's kind of annoying because it's like, well, I just made this parameter. I know what type it is. Why do I have to dynamic cast to get back to the type that I just created? So that's a little bit annoying. And then the annoyance gets compounded just because dynamic casts can be a bit expensive. And in a case like this, where maybe you're just doing all those dynamic casts at initialization time, it's not too bad, but it's still a little bit annoying. And then maybe you say, well, if you know what type it is, why don't you just reinterpret cast? And I guess you could try that if you want, but I wouldn't recommend it because if you try to dynamic cast and you get your type wrong, then you get a null pointer and it's pretty easy to debug what's going on. If you reinterpret cast and you get your type wrong, then you'll get what your C++ program will think you have a valid pointer to your parameter type, but in fact you don't. And then you can get all kinds of weird bugs that might be difficult to track down. So maybe don't do reinterpret cast if you can get away with dynamic cast or whatever you're using in that situation. So then this idea of thread clarity comes up. So this is probably something that a lot of folks have run into, where maybe you have some UI component and you want that component to disappear when some parameter is changed. So maybe you'll write code like this, where you have a value tree state listener, and then when your parameter changes, you can go through and say, hey, if it's this parameter, then change the visibility of my component. And the question that I'm going to ask is, which thread is this code going to be called on? And the answer is that it could happen on the UI thread, or it could happen on the audio thread. The UI thread case will usually happen if the parameter change came from the plugin UI. The audio thread case will usually happen if the host automation caused the parameter to change. And then you'll get the callback maybe on the audio thread. And what's kind of frustrating to me is that the JUCE documentation for the value tree state doesn't mention this. If you do a bit of digging, you can figure out that the value tree state listener is actually using a audio processor parameter listener, and the documentation for that does mention it, but you have to do a bit more digging. And that's kind of annoying because I feel like this is some code that it seems like the obvious way to do things. And it turns out to be wrong, but you may not know that it's wrong because maybe you're only testing your plugin in the standalone version, and then you don't have the case where your parameter change could come from host automation because you're not in a host. So it's kind of this sneaky bug that you wish the documentation or something like that would stop you from doing, but it doesn't seem to do that. So anyway, then maybe you say, well, okay, why don't I just use a parameter attachment for that instead? Because with a parameter attachment, I know that the callback for my parameter attachment will always happen on the UI thread. And in that sense, you're right. That will happen. That will be the case. But if you want to look at how the parameter attachment actually gets that to happen on the UI thread, this is the code that does that. So basically, your parameter attachment is a parameter listener and also an async updater. So when the parameter value is changed, the parameter attachment will check if you're on the message thread. And if you are, then it'll say, okay, call the listener right away, or call the callback right away. And if you're not on the message thread, then it will trigger an async update. And then when the async updater runs, then that will that will cause the callback to be called. So the question is this trigger async update function real-time safe? Because that's going to get called potentially on the audio thread. And according to the JUCE documentation, it is not real-time safe. So the JUCE documentation says it's thread safe to call this method from any thread, but beware of calling it from a real-time thread because it involves posting a message to the system queue, which means it may block. So that's not good news. And if we look at the implementation, we can actually confirm this. So if you dig kind of far down through the call stack of trigger async update, eventually you'll get to this function. And in here, we see that we are posting a message to the system queue. And that's where we run into behavior that may not be real-time safe. So that's a bit annoying. So now I was going to talk about my implementation for something that I've been starting to use instead of the audio processor ValueTreeState. And I guess before I do, I should mention that pretty much all of the code that I'm about to show you is stuff that I started writing maybe like 2 or 3 weeks ago. So it's just been a little bit of hacking that I've been doing. So I'll mention this more at the end, but some of this stuff is still a little bit rough and still going to get hopefully improved over the next couple months as I keep working on it. But I should also mention that there was a lot of work that I did before I started working on this, which actually made some of this process a bit easier. And that's kind of what this slide is about. So there's a few things that are kind of important for the implementation that I'm about to show. So one is that there needs to be some way of serializing the data. And this is just for saving and loading your plugin state. So JUCE likes their value trees for this, and the value trees do a good job. And the value trees map very well onto sort of the XML way of storing data. But maybe you would want to use JSON or some other format. So it'd be nice to be able to switch between different formats. And kind of something that goes along with this idea of serialization is this concept of reflection, which I'm not going to go too deep into now, but there is some parts where I'm using reflection to make this work. And the way that I do it is I use this boost PFR library and also this name of library. Don't be too scared of boost PFR. You can use it without boost, which is what I do, because yeah, boost is pretty massive. So maybe it's not something you'd want to bring into your project just because of how big of a dependency it is. But yeah, PFR can be used on its own. I also had implemented some custom parameter types. You don't really need to have these for what I'm about to show you, but there's one spot where it makes things a little bit nicer. There's also a lock-free queue that I'm using. There's a lot of good implementations of that out there. The one I'm using here is the Moody Camel reader-writer queue, but if there's another one that you prefer, that would probably work just as well. And then there's also a few spots where you need kind of this broadcaster-listener pattern. And JUCE has a way of doing this with their listener list, but I found this library called Rocket, which I think I like a bit better. It's got some nice benchmarks and things like that. And just sort of a slightly different way of organizing things, which I think I like better. The one thing I don't like as well is that they name things like signal and connection and things like that, which can be confusing when you're also working on an audio application. So I renamed a bunch of their classes to things like broadcaster and callback and stuff like that, which you'll see in a moment here. So when I started working on this, I was kind of thinking in this way where I was like, well, why can't we just do it this way? And so this is something that Eyal Amir showed me, maybe a year ago with some of his code, where he was like, well, what you would want to do is just have sort of a struct of parameters, and then the parameters would live in your plugin. And then when you need to access a parameter, you just go to the parameter like that. And I guess I think Eyal had some code that worked this way, and I could have asked him to borrow it or something, but I wanted to try to figure things out for myself. So that's kind of where the rest of this is going to come from. And the reason why you can't just do this as the code is written here is because the JUCE audio processor needs to own the parameters. So because this float parameter here is like a local variable, it's going to get deleted when the parameters struct goes out of scope. And so when the JUCE audio processor tries to delete the parameter as well, then you're going to get your double delete problem. So you can't do this directly, but there is another way that we can kind of make this happen. So first, I had to create this thing called an optional pointer. I'm not crazy about the name, but I haven't thought of a better one yet, so that's what I'm going with for now. And the idea here is that you've got two pointers. So you've got this owning pointer and you've got this non-owning pointer. And basically, when you create the pointer, it's an owning pointer. So you say, okay, I'm going to do make unique to create my object. And then I'm going to set the non-owning pointer to also point to that object. And then maybe at some point along the way, I want someone else to become the owner of this object. So then I can call release, and I can use no discard to make sure that someone else actually uses the value that gets returned from this function. So now the owning pointer is null pointer, but the non-owning pointer still points to the same data. So this is kind of handy. Then I can use my custom parameter types to, give them this little type alias. So I can say, okay, I want a float parameter pointer to be an optional pointer to a float parameter. And now I can do basically the same thing that I was doing before in the very first example I showed, the pre-ValueTreeState example, where I just go through and call this add parameter function for all of my parameters. Except now I need to do it with this release function. So after I call release on the parameter holder, it will still point to the parameter. It just won't be the owner of the parameter anymore. So I can create this plugin state, which is what I'm going to call my ValueTreeState replacement. So plugin state is parameterized on this params type. And then I can create the params locally and add them all to the processor like this. And then when I want to actually create my plugin, I can do something basically like this, where I create my parameters in a struct just the way I wanted to before. But now I'm creating pointers instead of just the parameters themselves. Then I can create this plugin state object, which is using this parameters type. The state lives in my audio processor. And then when I want to do something with my parameter, I can just access it pretty much directly like that. So that's kind of a nice thing. And I think I'm still getting used to writing code this way, but I think I like it a bit better overall. So now, why can't we just have parameter listeners that work maybe a little bit like this? So we have our UI component, and maybe we want to have this UI component also be a parameter listener. So we say, okay, I want my plugin state to add a listener. It's going to be this. It's going to be listening to this parameter. And I want the callbacks for the listener to happen on the message thread. And then in my param changed method, I can say, hey, if the parameter is being changed is this parameter, then I'll change my visibility. And I know that this is always going to run on the message thread because of this argument that I passed here. So the reason why we can't do this with the ValueTreeState listener is, first of all, because when the listener is called, the parameter might not have changed yet. So when we override ValueTreeState listener, we also need to have this argument for the new value of the parameter, which might not be equivalent to the value that I would get from like calling get on that parameter at the same time. So in order to kind of make that work, you kind of have to have that extra field to make sure you're getting the most up-to-date version, the most up-to-date value of the parameter. That's a little bit annoying, so maybe we'll see if we can work on that. Another problem with the ValueTreeState listener is we can't specify which thread the listener is going to be called on. So that's a little bit annoying, but again, we'll see if we can work on that. And then the third issue is that this code is actually incorrect. And the reason it's incorrect is because we never remove the listener from the plugin state when the UI component is deleted. And this is a kind of silly bug that I've run into probably at least like 20 times now, where like you do something like this and you test it again in the standalone version of the plugin and it works fine. And then maybe you test it in a DAW and it works fine. And then you test it in a DAW maybe like a week or two later, and you open the UI and you close the UI and you open the UI again. And now you get a crash because you have a dangling listener from the first version of the UI that you deleted previously. So yeah, that's kind of a silly bug that's unfortunately like a little bit weird when you're trying to test to, like, you'll run into that bug at weird times and not necessarily when you're looking for it. So it would be nice if there was a way to prevent that bug before it happened. So again, we'll come back to that in a second. So this is the way that I've been working on implementing listeners for my plugin state. And the way I'm doing it right now is I have this JUCE high resolution timer. So this is a timer that will run on a background thread. And then again, I have an async updater, but we'll be using it in a little bit different way, which you'll see. So then I have these param info structs. And in the struct, there's a pointer to your parameter, which I'll call the cookie. And there's the most recent value of the parameter. And we'll see why this is useful in a second here. So then I need to count how many parameters I have in my plugin state. And something that's kind of nice is that this is actually known at compile time because of, well, it's kind of tricky to make this happen, but you can do it at compile time. And so then you can have an array of param info objects. You can also have an array of broadcaster objects. These are broadcasters that are going to broadcast whenever the parameter changes. And we can have message thread broadcasters, and then we'll also have a set of audio thread broadcasters. And then we'll need this queue. And the point of this queue is basically to pass these messages between threads. So when we need a broadcaster to run, we'll have to pass a message from the high resolution timer thread to whichever thread the broadcaster needs to run on. And then that's going to make it happen. So this is where kind of the nuts and bolts of the implementation are laid out here. So first, we have to go through all of our parameters and create a param info object for all of them. So we just initialize them with the parameter pointer and the initial value of that parameter. Then we start our timer. So that's not too bad. And then in the timer callback, we go through every single thing in our parameter list and we check if the value has changed. And then if the value has changed, then we can queue up a message to say, hey, trigger the broadcaster for this parameter on the message thread. And then we can use trigger async update to basically make that happen. And actually the trigger async update is real-time safe here because we're not, or it doesn't matter if it's real-time safe because we're not calling it on the audio thread, we're calling it on the timer thread. And then finally, in our async update handler, we can just run all of our message thread actions. And you can imagine basically the same sort of thing would work for the audio thread version of the broadcasters, except that we would have to run them on the audio thread instead of on the message thread. So that's kind of the idea there. Then in our UI component, we can set up our listener this way. So we have this scoped callback object. And the idea with the scoped callback is that when it goes out of scope, it will delete the connection between the callback and the broadcaster. So we know that when the component is deleted, that the connection will be destroyed as well, and we won't have the dangling reference problem. So then when we create our listener, we say, hey, I want to listen to this parameter. I want to listen on the message thread. And when the parameter changes, I want to do this. And now we can just get the parameter value directly instead of having to get a value from the function or anything like that. And again, this is kind of a nuts and bolts thing, but this is what's actually happening when we add the parameter listener. And one thing that's kind of important to point out is that we can mark this function no discard. And the idea there is that if we forget to attach a scoped callback object to whatever thing is returned from this function, then we'll get a compiler warning. And that again is useful for avoiding that dangling reference issue I had mentioned. So it's kind of nice because something that previously would have been kind of a sneaky bug that we only would have found through a certain type of testing is now something that we'll get a compiler warning for. And we know that we'll be able to catch it that way. So I should mention that this is probably the part of my implementation that I'm the least sure about. So I'm pretty confident in the real-time safety. I think that the code that I've been writing, sort of the client code that I've been writing to work with this way of doing things, ends up a little bit neater than it was with the ValueTreeState. However, it seems a bit wasteful to create a new timer thread for every plugin instance. So like you can imagine maybe you have a session with like 200 plugins and maybe each plugin has its own background thread for doing this. Might not be the most efficient way of doing things. So maybe we could use like a time slice thread and share that between every instance of the plugin. Maybe that would help a little bit. Maybe we could just use a regular timer and have all this stuff run on the message thread. That's an option too. So that's something that I've been thinking about, and I'm just going to have to do some testing and see what seems to work the best. And then the other question is, what if the plugin is being used in like an offline rendering context? So the issue there is that the audio processing might happen much more quickly than the listeners are getting called. And so if the listeners aren't getting called quickly enough, things might not update in time, and you might get some weird behavior in the offline rendering. So in the testing I've done so far, this seems to be okay, but this is something I need to test with maybe a much bigger plugin than I've tested with so far, because I think that's where we might run into issues. So yeah, I'm still making sure that this is going to work, but yeah, we'll see what happens. And then finally, we say, hey, we want our parameter attachments to be real-time safe. Well, now we can do that with basically the same parameter listener method that we just walked through. So again, you have your scoped callback, and when you create a parameter listener, you set it equal to the scoped callback. We tell it, hey, we want this always to happen on the message thread. And now we can get parameter attachments that are basically the same as the JUCE parameter attachments, but now they've got some improved real-time safety. And so yeah, this is what it looks like in the sort of in the UI code. This is another kind of neat little trick that I figured out. So maybe we have some sort of nested parameters. So we have our parameter struct, and then we have a struct inside that struct, and that's the one where the parameter lives. So what we can actually do is make this little string-like parameter path. And the idea here is that we have the name of the struct and then the parameter ID. And that gives us the parameter that we're looking for. And it's kind of cool that this works, but I'm not sure I'm going to keep it in there just because I feel like it's going to lead to just magic strings everywhere and very messy code. So yeah, I'm probably going to get rid of that, but it's kind of cool that we can do it at all. So I was kind of happy that I got that to work. So finally, I just wanted to give a simple example of maybe a very basic plugin that uses this system. So maybe you've got a plugin and it has 3 processors that are doing things internally. So here's our processor 1, and it has some parameters. And so in the processor, we can have the parameters struct as a reference, and then we can initialize it in the constructor. And then when we want to make our whole plugin, we say, okay, well, let's make the parameters for each of the 3 internal processors. Maybe we have some other state. So this is a stateful thing that's not a parameter that we would want to save with the plugin state. We can do that too. I haven't really talked about that, but that's not too difficult. And so now you've got your plugin state, which has both the parameters and the non-parameter state. And then you create your processors. And when you want to initialize your processors, you can just do it like this, where you give them each their own parameters, and then they can manage everything from there. So yeah, this is something that I've been working with for the last maybe week or two. Like I said, this is a very recent bit of code that I've been writing, so I'm still very much working on it. It's still a work in progress, but I've been testing it out in a couple of plugins I'm working on at the moment. And so far it's been doing pretty well. It's definitely taken a little bit of getting used to since I've been using the ValueTreeState for a few years now. So using anything else, I'm sure would take getting used to. But I think it's going to work. And I also kind of took some risks along the way. So I did some things that maybe are as far away from the JUCE implementation as possible. And the idea there was that if it works out, then that's great. If it doesn't work out, I can gradually kind of go back towards what the JUCE implementation had, because I know that's going to work, and just live with that. And at the very least, even if I don't end up like using this, along the way, I learned a ton about how the ValueTreeState works. So that's been a really great experience for me as well. So in case you want to try out this way of handling plugin state, this is all part of my library. So I have this library that's just basically a bunch of JUCE modules. And the JUCE module that you're looking for is called ChowDSP plugin state. I should mention that some of the code in that library is GPL licensed, but everything that I've been showing today should be BSD licensed, and if it's not, let me know, because that means I did something wrong. So yeah, you should be able to use this code in pretty much any application you would like. And yeah, that's all I've got for today. So if you want to contact me, I'm on the Audio Programmer Discord, I'm on email, I'm on GitHub. So yeah, feel free to contact me anytime.
Fantastic. Thank you so much, Jatin.
No problem. Yeah, thanks for having me as well.
All good. So we have a few questions from Akash. Hey,
Cool.
Akash. And I think you may have talked about this earlier in your talk, but maybe not. So Akash says, one of the annoyances of using the value tree class is that it's notoriously difficult to inspect the contents of the tree when debugging. Is that something that has bothered you? And is that something that you account for in your implementation?
Yeah, I've definitely had that experience as well. I mean, I guess I account for it by not using value trees at all, which I don't know if that's really accounting for it, but it's just kind of taking a different approach. So yeah, I don't really use value trees at all in my implementation, but kind of as I showed at the end there, I've started setting things up where I basically have like these nested structs that have all of my parameters in them. And I've found so far that that's a pretty neat way to debug things, just because I can say, hey, I have, all of my parameters, or I have, just my processor one parameters or whatever, and then I can sort of fiddle through them in the debugger, just as like a sort of the debugger tree that I'm used to looking at. And that's worked out pretty well so far.
Great. And a nice compliment from Ismar, who says, thanks, Jatin, super clear. Always glad to improve my understanding of concurrent programming.
Oh, thank you. Yeah. I had to learn a lot about that as I was working through this as well, because there was a lot of things that were kind of new to me, and I was just, reading on the JUCE forum and reading in other, C++ blogs and things, trying to figure out what I should do.
Fantastic. Okay, any other questions? I will give a few seconds for anybody else to ask any questions. Okay, doesn't look like anybody. Looks like everybody's clear. Great stuff.
Cool.
Cool. Any thoughts, Rachel?
Yeah, it was a very clear presentation. Really enjoyed it.
Thanks.
So
Yeah.
thank you. I think
Cool.
I'll need to go back through it, fully understand everything.
Yeah, me too.
But
yeah, that's
glad
mainly why
we
I
got
put the
it
slides
recorded.
up there. Yeah, I figured there'd probably be some things that need a second or third look. Yeah, it's a lot of stuff, definitely.
Nice.
Cool. So yes, before we go, we'd like just once again thank our sponsors, Focusrite and Sonox, for sponsoring the Audio Programmer Meetup. Without you, this meetup wouldn't be possible. And thank you to the speakers, Daniel and Jatin, and thanks to everybody who tuned in.
Thanks for having us. And thanks for organizing, Josh and Rachel.
Yes. Oh, there was one more question for Akash. Where does the reflection come into play?
Yeah, so the reflection is kind of important for basically managing the struct of parameters and doing things with that as a whole. So like you might have seen in the code in a couple places, there was this function called like do for all parameters or something like that. And basically the idea there is that you have to loop through a struct of parameters. And then if you see a parameter, you say, okay, I'm gonna do something to that parameter. Or if you see a struct, you say, okay, now I need to loop through that struct. And so it's kind of this recursive thing. And C++ as it in sort of the standard form doesn't really have a way to loop through a struct. So that's where the boost PFR library was helpful for doing things like that. And that's kind of the same method that's used to save and load the plugin state and things like that. Yeah, so the reflection is pretty important for kind of managing all that stuff. and hopefully hiding it away so you don't have to think about it, and you can just make your structs and put structs inside structs and let it get taken care of. But yeah, it's certainly not at the point where it all just works yet. There's a lot of things that I'm still trying to figure out.
Great. Yes. So, yeah, thanks to everybody who tuned in. We are back in January. So even though we have the holidays, our next meetup is going to be right afterwards. We're going to keep this thing going. So, next date is the 10th of January. So join us. We have some, we already have some exciting guests lined up and some panels as well. So, so some exciting stuff coming up. A lot of really interesting advancements that are happening in the world of AI and in the world of audio, and yeah, a lot of great stuff to talk about for the new year. It's going to be a great year for audio software development, and I think for software development in general. Really exciting. So, and with that, once again, thank you to the speakers, Daniel and Jatin, and thank you to Rachel for co-hosting as well. And we hope
Thanks,
that you
Steve.
have a happy holiday, and we hope to see you on the Audio Programmer Discord or see you next month. And with that, we will let you go. Everybody have a great day, and we will see you in 2023. That's the first time I've officially said that. So, see you next year.